Okay, today we're going over 6.6, the fundamental theorem of algebra. Today is going to be a continuation of 6.5, and we're just going to be adding on a little bit more from the 6.5 lesson. So, for example, if we have the equation of this cubic polynomial of 4 terms, and we want to find the number of complex roots, well, then we're going to look at the highest degree, which is a 3. So the number of complex roots is always going to be the highest degree, so in this case it's a 3. And complex roots, that just means that it's in the form of a plus bi, where a or b can be 0, so therefore it's really made up of real numbers and imaginary numbers. The next thing is looking at the number of possible real roots. And what that's doing is it's listing the number, meaning how many possible real roots can we have. So from the imaginary root theorem, we know that we can only have an even amount of imaginary numbers. So therefore, we can make a little chart here to make this easier. This is a capital R with a line through it, means real numbers, and I for imaginary numbers. So we can start off with the imaginary numbers and then fill in the real numbers. So we can say there are 0 imaginary numbers. There can be 0 imaginary numbers, imaginary solutions. Therefore, it would be 3 real solutions because it has to add up to 3 complex numbers altogether. So this is one option. We want to say, okay, can I have 1 imaginary number? Since the imaginary root theorem says that you have to have an even amount of imaginary numbers, then you cannot have 1 imaginary number. For example, if I have a 2i, then I'll also have a negative 2i. Moving on, we can have 2 imaginary numbers. Therefore, we would have 1 real because 2 plus 1 will give us 3 answers or 3 complex roots. And that will do it for that. So we can have either 3 reals or 1 real solution. The possible rational roots here, that's when we're going to list the factors of the constant over the factors of the leading coefficient. And the leading coefficient we know is the number in front, the coefficient or the number in front of the variable with the highest degree. So we're going to list the factors of our constant, which is a negative 6, over the factors of our leading coefficient, which is a 1. So list those out, plus or minus 1, 2, 3, and 6. And we would divide all of this by the factors of 1, but since that's a 1, that's not going to change it when you divide by 1. So these are the possible rational roots, meaning this is what it could be. This is where it could cross your x-axis. Okay, so that's all that problem asked for. And then we can move on and find out all of the zeros of the polynomial function. So we can go through that process by, let's say that we have a 12x cubed minus a 32x squared plus 25x minus 6. And we want to find all the zeros. Find all the zeros. Okay, so we can start by listing the possible rational roots. And the possible rational roots will be the factors of our constant, which is a -6, over the factors of our leading coefficient, which is a 12. So we'll list all of these. Make sure you always put plus and minus for each one. So we have 1, 2, 3, and 6. And for the 12, we have 1, 2, 3, 4, 6, and 12. So I made sure to put one in where the leading coefficient is not 1, so that now we'll see that we have to divide all of these to find all of the possible rational roots. So this one has quite a few. So we'll go ahead and divide all of them. We'll start with the 1. 1 divided by 1 is 1. 1 divided by 2 is a half. 1 divided by 3 is a third. 1 divided by 4 is a fourth. 1 divided by 6 is 1/6. 1 divided by 12 is 1/12. Moving on to the 2. 2 divided by 1 is a 2. 2 divided by 2 is a 1, which we already have, so we don't have to rewrite it. 2 divided by 3 is 2/3. 2 divided by 4 is a half, we have that. 2 divided by 6 is a third, we have. 2 divided by 12 is 1/6, we have. Moving on to the 3. 3 divided by 1 is 3. 3 divided by 2, 3 over 2, or 1.5. 3 divided by 3 is a 1, we have. 3 divided by 4. 3 divided by 6 is a half, we have. 3 divided by 12 is 1/4, we have. Moving on to 6. 6 over 1 is 6. 6 over 2 is a 3, we have. 6 over 3 is a 2, we have that. 6 over 4 reduces to 3 over 2, we have that. 6 over 6 is a 1, we have. And 6 over 12 is a half, we have that. Okay, so these are the possible rational roots. This is what it could be. So now we're actually going to test these by using synthetic division. And if you download the app Desmos, you can use this app, or you can use it on your computer at home, or you can use your graphing calculator. So from all of these, we're going to test them using synthetic division, and we are trying to find where these cross, where this cubic polynomial of 4 terms will cross the x-axis. So I'm going to plug it into my Desmos app, and I found out that it crosses it at a half, so I'm going to use that one. And what we're trying to see here when I use this is if the remainder will be 0. So I'm going to use synthetic division here, listing all of my coefficients. Bringing down my first coefficient, 12, multiplying. Half of 12 is a 6. Adding these, that will give me a -26. Multiplying, I'll get a -13. Adding, I'll get a 12. Multiplying, I get a 6. Adding, I get a 0. So we remember that this is going to give me the remainder, and then we can move on to the next one. This will be my constant term. The -26 will be the linear term, and this will be my quadratic term. So now I already know that x equals 1/2 is one of the solutions, and I'll find the other 2 because I know there's 3 altogether. So I'm going to now use this to find my other zeros. So I'm using 12x squared minus 26x plus 12. I'm going to set that equal to 0 and solve for x. So since it's just equal to 0, I can go ahead and divide everything by 2 so that it's smaller numbers. And I'll come out with this. And then I'll plug it into the quadratic formula song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so we'll plug that in. We have x equals negative 13 is 13. Plus or minus, we'll plug that in. And we'll go 13 squared is a 169. Minus 4 times a times c. So 4 times 6 times 6. Move that over a little bit. So 13 plus and minus the square root 169 minus 4 times 6 times 6 all over 2 times 6. Okay, so then we'll multiply that out, and we have 13 plus and minus the square root of 169 minus 6 times 6 is 36 times 4 is a 144 all over 2 times 6 is a 12. We get a 13 plus and minus the square root of 169 minus 144, which is a 25 all over 12. Coming over here, I'll get x equals 13 plus or minus 5 all over 12, and then we can break this up. 13 plus 5 over 12, and 13 minus 5 all over 12. So 13 plus 5 is an 18 over 12, and then we can divide out a 6 from both of these. So 18 divided by 6 is a 3. 12 divided by 6 is a 2. So that's one of our answers. 13 minus a 5. Oops. We'll subtract that. And we'll get an 8 over 12. And then we can divide both of those by a 4. And we get 2/3. So those are our 3 answers. We got a 1/2, 3 over 2, and 2 over 3. And those are our 3 answers.